Want to stop your Python scripts from crashing when things go wrong? Stay tuned because in this video we are mastering Python try except blocks to make your programs smarter and more resilient. First, let's start by showing why error handling is critical and what happens when it is missing. I will write a simple Python script that asks for user input and divides it by a static number. Start by defining the constant integer 10. Ask the user for input and convert the response into an integer for the division. Perform the division and assign the result to the variable result. Print out the result of the division. Let's run this in the terminal. When you enter 2, the program performs the division and prints the result. When you enter 0, the program crashes, displaying a 0 division error in the terminal. Without error handling, even small mistakes from the user can crash your program. But don't worry, we will fix this in the next segment. So, we have seen what can go wrong when errors are ignored. Errors are inevitable, but instead of letting your program crash, wouldn't it be better if it responded with helpful feedback? That's where Python try except comes in. The try block contains the code that attempts the division. If the user enters 0, Python raises a 0 division error. The except block catches this error. Inside the except block, display a message informing the user that division by 0 is not allowed. Time to execute the script. When you enter 2, the program performs the division and prints the result. When you enter 0, the program shows an error message instead of crashing and keeps running. Now, even if the user makes a mistake, your program stays intact and provides guidance. Simple but effective. We have tackled one type of error so far, but real-world programs often face more than just one kind. What if the user enters unexpected input, like letters instead of numbers? Let's see how to handle multiple exceptions gracefully to create a smoother experience. If the user enters 0, the except 0 division error block catches the error and displays a message explaining that division by 0 is not allowed. If the user enters invalid input, like textual 10, Python raises a value error. The except value error block handles this error and informs the user to enter a valid number. Let's run it and see what happens. When you enter 10, the program shows the invalid input error message. When you enter 0, the program shows the division by 0 error message. When you enter 5, the program performs the division and prints the result. By handling multiple exceptions, you make your program resilient and user-friendly, no matter what gets thrown at it. While built-in error types cover many scenarios, sometimes you need specific rules for your program, like rejecting negative numbers. That's where custom exceptions become handy. Define a new custom exception class called negative number error to handle cases where the user enters a negative number. In the try block, check if the user input is negative. If it is, raise the custom exception manually with a message explaining that negative numbers are not allowed. The except negative number error block catches this specific error and displays the message provided when the exception was raised. Try this out in the terminal. When you enter -10, the program shows the custom error message. When you enter textual 10, the program shows the invalid input error message. And when you enter 5, the program performs the division and prints the result. Custom exceptions let you define specific rules for your program, giving you flexibility and control. Now that you have mastered how to manage errors, let's take it one step further. Python's else and finally blocks give you even more control over how your code behaves. Sometimes your program needs to take specific actions only when no errors occur, or you want to ensure cleanup tasks happen no matter what. That's where else and finally blocks come in. The try block attempts to open and read a file named data.txt. If the file doesn't exist, Python raises a file not found error. The except file not found block catches this error and displays a message telling the user that the file is missing. The else block runs only if no exceptions occur in the try block. It prints a success message and displays the content of the file. The finally block ensures cleanup tasks such as closing the file are always executed even if an exception is raised. Inside the finally block, add a nested try to safely close the file. If no file was opened, Python raises a name error, which is caught and handled with a friendly message, no file to close. This ensures the program remains clean and error-free. Execute the code and check the result. When the file data.txt exists, the program displays its content and closes the file successfully. When the file is missing, the program shows the error message but still performs cleanup tasks. The else and finally blocks give you control over what happens during success and ensure cleanup in any scenario. With these techniques in your toolkit, your code can handle anything thrown at it. Let's wrap up with a quick recap. Now you know how to handle errors in Python using try, except, else, and finally blocks. These tools empower you to make your programs more user-friendly, readable, and robust. If you found this video helpful, don't forget to like, share, and subscribe to the channel for more Python tutorials. Have any questions or your own error handling tips? Leave them in the comments below. I would love to hear from you.